about 18 months ago, we had a presentation from you when you first started this survey, and some of us did submit samples of honey to be analysed to form part of your results into what is actually the composition of Australian honey. So over to you. Thank you, Jamie.
Thanks, Barry. I'd just like to acknowledge my offsider, Leanne Groves. She put a lot of work and effort into this project as well. So we'll start talking about why we did the project. It was a joint project between New South Wales Department of Primary Industries and funded by Agrifutures. The reason we did the project, we wanted to develop accurate, reliable analytical methods for honey analysis. Sounds a pretty simple thing, but we work with a lot of different industries, and getting everyone to use the same or similar methods and ensuring they're accurate can sometimes be a challenge. So we wanted to try and do that. Once we had those analytical methods in place, we wanted to establish a database of the composition of Australian honey. For those reasons, that it's good for food defence. So if anyone ever questions anything about the honey produced in the country, you've got this scientific data backing up any claims that we make. We'll talk about the Australian standard later, but we reckon this information could go towards producing an Australian standard. And just being able for the leaders in the industry, I guess, to be strategic about how they can use this information in the future. As with all the products we work with, so we just so you know, we work with olive oil here as well. We do a lot of work with olive oil, canola, all sorts of things. But yeah, we want to provide a service to the industry where people can get the honey tested and ensure that the quality of the honey that's been marketed is up to scratch. So as Barry said, we spoke to you probably 18 months ago, and we hadn't really started. We'd done maybe 50 samples. We'd developed all the analytical methods. And as part of that, we wanted to make sure that we were getting accurate results from those methods. So as with our other products, we're involved in these laboratory proficiency programs where we have samples sent in to us from proficiency programs. We do the analysis, send the results back and see how accurate we are. Quite expensive. I think I paid €600 for something like 80 grams of honey, but you're not paying for the honey, you're paying for the data that comes with it. So the programs we're involved with had about 50 participants, so they just take the mean and look at the variation, and you can tell how well you are or are not doing. I put across through the work in progress there, just because when I spoke to you, the collection of the honey and the actual reporting and everything was a work in process, but it's now completed. We wrapped it all up earlier this year. There's a report available, and I'll tell you a bit about that in a minute. So we ended up getting 3 years or 3 production seasons in, which was good. We were able to send individual reports to the beekeepers during the project so that they could get immediate feedback regarding their honey. Yeah, there's a final report and we're disseminating results doing things like this tonight. When we collected the samples, we asked beekeepers and packers to provide honey to us. Beekeepers really like to keep certain information to themselves, which is fair enough, just in terms of location of hives and things like that. So we just asked them for some general information about where they were producing this honey, how they were storing it, and all identifying data was removed. Give information down the local government area region, but that's a smaller region as we go. Everybody got a report. That's an example of a report there. So we would just talk about what the results were for that individual honey sample, and we compared it to the CODEX standard limits so people could see how their sample fitted in. So what I'm going to talk about now is the combined results for all samples. We did break it down into what happened in the individual states. You can look at that in the final report, and that final report is at that address there. If anybody wants to download it, it's free. You can just search for composition of Australian honey on the Agrifutures website and you'll find it as well. And like I said, that final report will talk more, it goes into more detail than we will tonight about sample collection, the methods we use, some other detailed results on things like the individual sugars and fructose to glucose ratio and things like that. In terms of the samples we got, we ended up with almost 300. We were pretty proud of that. It was really slow at the start because we're in the COVID sort of era at the start, so things just slowed down a lot. So it was a bit of a hard slog getting samples in, but we were happy with the breakdown. We probably would have liked more samples from some of the states, Tasmania, and Victoria, I guess. But yeah, we think there's enough there to give us a general view of what's happening. Obviously, there's a lot of beekeeping happening in New South Wales, so we ended up with 40% of our samples coming from there. We even had 2 from Northern Territory, which were interesting. They gave us a few interesting results. Of the 288, we removed 4 for various reasons, and we'll mention those a bit later in the presentation. So, like I said, we identified the local government areas where the samples came from. So you can just see that there. We're pretty happy with the spread. It's from most of the beekeeping areas in Australia. There's the couple up there in the Northern Territory. We got some from WA and South Australia, but yeah, pretty pleased that we're able to get them from a lot of different areas. Really good, so we can get the real range of what's happening with Australian honey composition. I made a little word cloud of the floral sources that were provided for those samples. So as you can see, mallee, red gum, mixed blend were fairly popular. Some of them only mentioned once. We don't want to make any assumptions based on those floral sources. That wasn't the point of the project, but we just thought it was interesting to see the breakdown of what we're able to get. You might ask why I'm going to talk about the different components I'm about to. This is why. This is the honey standards, both the Australian and CODEX and the EC honey standards. The food standards, Australia and New Zealand, is pretty simple. It's just that description of honey, a natural sweet substance, blah, blah, blah. Less than 21 moisture, and fructose and glucose, the sum should be greater than 60. It's a bit more comprehensive for CODEX and EC, and I'll explain why each of those components are important as we go. Start with moisture. It's important. As you guys know, if it's low, it makes your honey difficult to handle and process. If it's high, it's more likely to be fermentation. It has some effect on the physical properties of the honey as well. How's it measured? You've probably done it yourself with a refractometer. Ours is the same as yours, just a bit more fancy. We do it all at a controlled temperature. And not only at a controlled temperature, in our calculation, we bring everything back to 20 degrees, just so everything's comparable. You guys know what affects moisture, so I won't go through that. Results were a range of 13.6 to 22.4. You can see I've written there the CODEX limit is less than 20. We had a mean of 16.7. There were 2 samples that exceeded the limit, though, both from the same beekeeper in South Australia, similar floral sources. So they're outliers, but they're probably easily explained. Something to do with the way they were processed, those samples. But in general, the Australian honey quite a bit lower than the CODEX limit. pH, obviously it's measured with a pH meter. Affected by floral source and storage. And it's important because it inhibits microbial growth or microbial spoilage in the honey. There's actually no CODEX limit for pH. Our range was 3.5 to 5.5 with a mean of 4.2, but as you can see, most samples were between that 3.8 to 4.6 range. For acidity, it's important because it's measuring the degradation of sugars in the honey. And if it's high, it can be an indicator of fermentation during storage. That's Leanne there. So she's titrating sodium hydroxide into a honey sample and we titrate it to a certain pH, and that tells us the free acidity in the honey. It's affected by all those things, floral source, geographic region, seasonal and storage conditions. And there are organic acids that naturally occur in honey, so we're measuring those. I had an interesting call today. I think oxalic acid was something to do with controlling varroa mites. They're asking, is that going to cause problems with the honey? I don't know. It just thought it was an interesting question. We would probably pick it up. This free acidity isn't specific organic acids. It's a total acid test. But it'd be interesting to see if a treatment had any effect. There's the results you can see. So the mean was 18.7. CODEX limit is it needs to be less than 50. So we more than met that requirement. We did have a couple, one that exceeded the CODEX limit, but you can see it's from far north Queensland. It was labelled a mixed rainforest species. And the other parameters that we measured with that honey, the HMF and diastase, were also outside the limits. We suspect that it was the conditions in which that honey was produced that caused those results to be out of spec. So, and by that I mean the heat and humidity and everything in far north Queensland. We measure a thing called diastase. It's a naturally produced enzyme. It's produced by the bee. When the nectar is regurgitated, diastase comes with it. It's important because the diastase activity decreases if the honey's heated during processing, or it just naturally changes over time. So it's a useful indicator of freshness and overheating during processing and storage. How do we measure it? We add different chemicals, and the enzyme that's there breaks down those chemicals, and we're able to see that blue color you can see in those test tubes, and we measure that with a spectrophotometer, and we're able to calculate how much of this enzyme is in the honey. It's affected by all those things: floral source, geographic region, origin, seasonal conditions, but probably, or in my mind, most importantly, is storage conditions and the age of the honey. So we want it to be greater than 8 units, and the units are diastase activity on the shade scale. So we want to be greater than 8. Our mean was 23, and we had one as high as almost 64. I'll just explain this less than 0.8 for you. For all of our analytical methods, for those of you who don't know about limit of quantification, all of our analytical methods have a lower limit below which we can't accurately measure something. So for this particular method, the lowest we can accurately measure is 0.8. So as you can see there, more than 85% of the samples are greater than 15, which is well above that cutoff of 8. The 2 samples that were below were both from WA. They were from different beekeepers, but they were both from Western Australia, very close geographically, but we couldn't see any common floral source or descriptions. So there's some link there, but it wasn't immediately obvious to us. HMF is 5-hydroxymethyl perfuril. So why is it important? It's a product that's formed by the degradation of sugars. Should be absent or very low in fresh food. We measure it with a high performance liquid chromatograph with a photodiode array detector. So that's Leanne and I pretending to put some samples on there in that photo. It's affected by heat. So increased heat during processing and storage will cause HMF to increase, and just over time it'll increase regardless of how it's stored. The cooler the storage, the slower the increase, but it'll increase. So this graph shows you the results for the HMF. So our mean was 7.3. Our range was 1 to 99. We wanted to be less than 40 milligrams per kilogram. So we're well and truly below that CODEX limit. In fact, as I say there, more than 90% were below 20, which is great. For the 6 samples that were above the limit, the highest were from the Northern Territory and those far northern Queensland honeys. So we suspect, like I said before, those tropical areas, it's really hard to control the heat when the bees are making the honey during processing, during storage. So we suspect that had an influence on those results. The two that were just above the cutoff, they were between 40 and 45. One from New South Wales, one from South Australia. Again, no indication of any commonality between them. It was just, we'd have to look further to see why that was the case. I said before we'd talk about the 4 samples we excluded. That is these. So sample A, when the person submitted the sample, they said, look, our processing equipment had a failure, or we know the honey was heated to above 65 degrees for a prolonged period. You can see what happened with the HMF, went up to 320 almost. So you had this huge degradation of sugars, and the enzyme activity, the diastase, was destroyed, as you expect with prolonged heat applied. Sample B, we withdrew. Again, the submitter told us it was more than 20 years old. It was a good little experiment to see what happened with that old honey, very high HMF and low diastase activity. C, we didn't have any information come along with the sample, but it was just weird. We couldn't see, we measured peaks on the HPLC and we just couldn't see any HMF peaks. It was odd. Still haven't sort of nutted that one out. And D, you can see something went terribly wrong. Almost 600 HMF when it needs to be less than 40. And the enzyme activity very, very low. So something's went terribly wrong during the processing of that sample. So that was a little interesting little sort of side experiment. And we didn't want to include them with the main data because we thought it would skew them unfairly when there was obviously something terribly wrong with those. Sugars, they're important because they contribute to the physical and nutritional properties of the honey. Again, we use a HPLC with a different detector, a refractive index detector. We measured fructose, glucose, and sucrose. They're affected by the floral source, obviously. The nectar that the bees are collecting will have an influence over the sugar composition. You guys know more about how early extraction affects it than me, so I'm not gonna pretend I know a lot about beekeeping. Supplementary feeding, if you're sugar feeding your bees to get them through winter, that can have an effect on the honey production. I don't want to talk too much about adulteration with this because these aren't the perfect analytical methods for indicating adulteration, but it can be used as an indicator of adulteration, but you would need other tests to confirm. The standard for the sum of fructose and glucose CODEX limit is greater than 60. Our mean was 70.4 and the range, 63 to almost 80. So 100% of our samples met that requirement and are generally well above the CODEX limit. Just a bit of information there about some particular blends. As I said before, it wasn't our intention to talk about monoflorals. It wasn't the intention at the start to make any assumptions about any floral sources or anything, but just for information, the canola or canola blends tended to be relatively high for their fructose and glucose concentrations. The Yapanya was relatively high as well, but there's only 4 samples. At that lower end, there was no common traits, which was surprising because there were some, in the 62 to 65 range. We thought there might be a common floral source or a common geographic area, but we couldn't see anything there. Sucrose is interesting. As I said, with the limit of quantification earlier, we set that by doing all sorts of tests, and that ends up becoming the lowest amount we're prepared to report accurately. And we have to do this as part of our quality control. And you can see our mean is lower than the limit of quantification. It just means that the sucrose content that we saw from these 300 samples was very low. The CODEX limit is 5 and our mean is less than 0.5. So you can see there 73% samples less than 0.5 and 90% less than 1. So it's well below the CODEX limit. We did have 2 samples that were above the limit, one in New South Wales and one in Victoria, but there was no additional indicators as to why. Like, we did go back to the beekeeper and ask about supplementary feeding, or if they could tell us why the sucrose might be high in those samples, and they're unable to identify any particular reason why that occurred. Conductivity, it's a quality control measure. It's obviously measured with a conductivity meter. The floral source, mineral content, and organic acids can have an effect. These results are interesting. The CODEX limit is 0.8. Our mean was 0.56, a range from 0.5 to 1.91. So 16% of the samples were above the limit, and it wasn't one particular region or a particular floral source. It occurred in every state, with the exception of Northern Territory, where we only had 2 samples anyway. I guess the common thing we did see, if beekeepers had multiple submissions, if one was high, they were all high. Is it something to do with the way they're processing their samples? I don't know, because we'd have samples from close by, from other beekeepers, that wouldn't show the same results. We couldn't say it was geographic or a particular floral source. So it may come down to beekeeping practices that saw those high results. Water insoluble solids, it's important because it can tell you a bit about the sample appearance. How do we measure it? We filter it through that flask there with water at 80 degrees until there's no more sugar being washed out of the sample, and we can test that with certain chemicals. It's affected by hive maintenance and processing. Again, interesting results. So the CODEX limit is less than 0.1 grams per 100 grams. Our mean was exactly on that limit, and we had a range of less than 0.2 all the way up to 1.2. So 27% of the samples were above the limit. Again, every state or territory except Northern Territory had samples above the limit. Just anecdotally, we thought there were 3 distinct types of solids that we were seeing in the filters when we finished. So there was that waxy solid, or a dusty sort of pollen solid left in the bottom of the filter, or bee parts, and everything from a wing or a leg to entire bees sometimes. We did ask for samples straight from the hives, because we didn't want to change any of those other things we've been talking about. If you start filtering and things like that, you do start to change the composition of the honey. We were surprised by what we found in some of the samples, to be honest. So the conclusions of the work are Australian honey is diverse. The geographic spread of where honey is produced in Australia is massive. So that is going to result in a lot of variation in the honey that's produced. The climatic conditions where the honey is produced does have a role in the composition, the floral sources available, and the flowering patterns. Again, not being a beekeeper, things kept occurring that were surprising to me, and one was you'd get an influx of, say, green mallee, I think was one of them. You talk to beekeepers and ask why you were getting them, and they'd discuss with us how the flowering patterns and seasonal conditions can affect exactly where they're drawing their nectar or their honey from. We generally meet the international limits with Australian honey. In some cases, we considerably exceed the limit in a good way, and we're just wondering if there's marketing opportunities for Australian honey. We can't compete on production levels, but we certainly can on quality. And again, with the other crops that we work with, like olive oil, it's the same thing. We're a small producer in the global context, but our product has got a lot of good quality, or a good story around the quality and how it's produced. And we're thinking that maybe the industry could use that as some marketing opportunities to get a better price for their product. So as I said, some of the parameters, there was a non-compliance. We just have to think about that and why that's happening, and maybe the type of samples that we're testing in the future. Future research, from our point of view, we'd like to continue to collect samples for this database. We'd never really capture composition of honey. You could do it for 20 years and there'll be different flowering events and different things that happen. But the longer you can do it, the more comprehensive the database will be, and the more information beekeepers will have to make their decisions. Like I said, we'll have a discussion about what type of honey we use in the future. There's some pros and cons. If we start using processed honey that's been filtered or heated, we might change some of those other parameters. And whether if that's what the industry wants, we're happy to go down that pathway. We need to find a quick, inexpensive, accurate way of measuring some of these things. We did do a bit of work with near infrared. And yeah, I won't go into it other than to say there are methods you can use that are a lot quicker and a lot cheaper, and we would like to work on those to try and give beekeepers a way to measure some of these things that are inexpensive and can be done relatively quickly. I'm always astounded that we'll individually do these projects and with the same funding bodies, and there could be a lot more efficiencies if we were all working on the same samples. So I've met a lot of researchers in different disciplines. The antimicrobial activity or the bioactivity of honey is something that I think is really important. It's not something we can do, but we can all work on the same samples and have an entire package. I think that'd be great. So that'll be one of our approaches to the funding bodies. How can we be as efficient with what we're doing as we possibly can? And I think unique traits of Australian honey to use as a marketing tool might be something we could use in the future. Just some acknowledgements there. You don't do anything like this on your own. So just everybody that's helped, we really appreciate your help.
Barry, I see that Decca's got a question in the chat.
If you're to test for antimicrobials in the future, would you focus on MGO, UMF, TA, NPA, etc.?
I'll be as quick as I can, but I'll say that every industry we work with, there seems to be these little groups of people that get angry with you sometimes. We would love to test. We'd probably do MGO and DHA, and we can come up with. There's been work done at the University of the Sunshine Coast by Peter Brooks. He's got a calculation that he's developed. Unfortunately, we can't do anything off our own bat. We need funding to do all the work that we do. So as much as we'd love to, we need to find someone that's willing to help us out with that. More than happy to do it, but I don't think Agrifutures are interested in going down that pathway at the moment with their work.
Thanks, Jamie.
And I'll wrap it up there, and thank you for your time.